Outdoor flash photography can be a nightmare if you don't understand the basic rules. How to set the correct settings to balance the model and the background. How and when to use high-speed sync. Why do photographers use neutral density filters when shooting with a flash? We'll delve into these and other important topics in detail now. To make it simple, all settings in this video will be done manually. But once you understand manual settings, it will be easier to learn the automatic settings if you need to. As you know, when shooting with constant light, you can affect the brightness of the photo with 3 camera settings: ISO, shutter speed, and aperture. Flash is an impulse light source, not the constant one. In contrast to the constant light, it first accumulates energy and then releases it in a split of a second. For our further considerations, let's assume that this pulse has an extremely short duration in time. When shooting with a flash in a completely dark room, it doesn't matter what shutter speed we set on the camera: 1 second, 2, or 30 seconds. That is, it doesn't matter how long the camera's shutter was open because the sensor was only exposed to light from the flash, and it happened in a brief moment. So when shooting with a flash in a completely dark room, we lose one of the camera settings that affect the brightness of the shot: shutter speed. However, we gain an additional setting: flash power. That is, the brightness of the shot will change if we change the flash power. Don't be scared by these eyes with a crazy look. All these shots were taken in complete darkness, so the pupils are dilated. So what happens when we shoot with a flash outdoors? In this case, we already have 2 different light sources: the flash and daylight. Let's try to think about them separately. Let's start with the simplest scenario. We are shooting a person against the evening sky, but no ambient light falls on the person's face. The face turns out dark, and we will light it with a flash. Of course, the power of our flash won't be enough to light up the sky and horizon as well, which are too far away from us. Thus, we get a separation. The sky is illuminated only by ambient light, and the person will be illuminated only by the flash. Where to start setting up? First, forget about the flash and even the person you're shooting. Just set up the camera so that you visually like the background. That is, set the ISO, shutter speed, and aperture to your liking. Now it's time to turn on the flash. Let's analyze how the brightness of the person will change when changing the flash and camera settings. Changing ISO and aperture will lead to a change in brightness of both the background and the face. The brightness of the face will also be affected by the flash power. However, changing the shutter speed within the typical values for such shooting will not affect the brightness of the face. This table reflects the dependence of the brightness of objects in the frame on changing the camera and flash settings for the situation when the person is not illuminated by ambient light, only lit by flash. By analyzing this table, we can make important conclusions. If you want to change the brightness of the background only, change the shutter speed. If you want to change the brightness of the person only, change the flash power. If you want to change the brightness of both the background and the person with one setting, change either the aperture or ISO. We started with a simplified evening scenario in which the person's face is illuminated only by a flash, so changing the shutter speed does not affect the brightness of the face, just like when shooting in a dark studio. Most of the time, the face is still illuminated by some existing ambient light. Take a close look. It's clearly visible that when the exposure time is increased, the shadow part of the face becomes brighter. That is, the contrast between the illuminated and shadow parts of the face decreases. Be sure to consider this when shooting, as well as the fact that the color of light from the flash may differ from the color of ambient light, meaning there is a chance to get mixed color lighting in the shot. That is, different parts of the face will have different color shades. This was a simple example. Now let's look at more complex shooting conditions and the problems we will encounter in them. One such problem, when shooting with a flash outdoors during the day, bright daylight doesn't allow you to shoot at wide apertures and nicely blur the background without some extra tricks. Why does this happen? Most modern cameras have curtain shutters. How they work is simple. There are 2 curtains that cover the frame window. When taking a photo, one curtain opens, letting light go through the open window to the sensor. After some time, the exposure time, the second curtain closes off the light path to the sensor. This process is fast but not instantaneous, and it is technically impossible to achieve very short exposures due to the limited speed of the shutter curtains. And to get very short shutter speeds, engineers used a trick: Before the first curtain is fully open, the second one starts to close. This way, light affects each part of the frame for less time, reducing the exposure time. In other words, a gap forms between the curtains, and the smaller the gap, the shorter the exposure time for each individual area of the frame. When working with a flash, this gap becomes a problem. At long shutter speeds, the curtains have a fully open position, during which the flash can light up the whole frame. The shortest shutter speed, where the shutter window is fully open, is mentioned in the camera manual and is called flash synchronization speed, or sync speed with flash, or X-sync shutter speed. In modern cameras, sync speeds are approximately like this. But at short shutter speeds, part of the frame is covered by a curtain when the flash fires. As a result, the shadow from the curtain appears as a dark stripe in the photo and spoils the photo. That is, as soon as the first curtain is fully opened, the flash fires, and if the exposure is shorter than the sync speed, the second curtain starts to close and creates an obstacle to the light by that time. Remember, for the sake of today's examples, we're assuming that the flash is instantaneous. To solve the problem of the curtain shadow, many modern external flashes include a special mode called high-speed sync, or short exposure sync. The high-speed sync mode allows for even illumination of the entire frame while shooting at very short exposures. The essence of the mode is that it essentially turns the flash into a continuous light source. Instead of a single short pulse, the flash emits several pulses of equal power in quick succession. However, these pulses are less powerful than in regular mode. As the stored charge has to be spread over a longer period of time, our eye doesn't see the multitude of pulses, and from the outside it looks like a regular flash, just longer in duration. This duration is enough to illuminate every area of the frame while the shutter gap is moving, much like what happens with continuous light. Now let's move on to examples. This time we will look at more complex shooting conditions than last time. Both the face and the background are sufficiently illuminated by light that has passed through clouds. Initially, we took a photo without a flash with the settings you see in the picture. This portrait could satisfy us, but in this case, we don't like the lighting on the face. The direction of the light is too top-down, creating an effect called panda eyes. More details about the drawbacks of top-down and bottom-up lighting can be found in another video. The link will be in the description. We can correct this top-down lighting flaw by additionally illuminating the face with a flash, thereby adjusting the existing lighting. The camera settings remain the same. The flash just added light to the already existing lighting, slightly improving it. So far, no problems arise, but if we want to open the aperture to 1.4 to blur the background more, we will encounter difficulties. With such an open aperture, we will have to reduce the shutter speed to 1/400 of a second, which is shorter than the sync speed, and that's where the high-speed sync mode in the flash settings comes to our aid. Note that when you enable this mode, the brightness from the flash in the frame will be a couple of stops less, as its charge will now be consumed by multiple pulses. Therefore, we increase the flash power from 1/16 to 1/4. In general, high-speed sync mode is convenient, but it has a specific feature. Essentially, in this mode, the flash almost becomes a constant light source, meaning that reducing the shutter speed will now change the brightness of the face illuminated by the flash. Remember our previous table? It has now changed a bit. Now we've lost the ability to change the brightness of the background independently of the brightness of the face. We used to do this using only one setting, by changing the shutter speed, and if, for example, we need to darken only the background, we will now have to do this in 2 stages, not 1. First step, reduce the overall brightness of the entire shot using shutter speed, aperture, or ISO. Second step, increase the flash power. Don't forget that in this example, the shutter speed significantly affects the lighting contrast on the face. This is because the face is lit by ambient light almost as much as the background. So, as the shutter speed increases, it becomes harder for the flash to compete in brightness with ambient light. In other words, you can't make the background very bright while achieving very contrasting lighting on the face at the same time. This is possible only if you build a setup that shields the person from ambient light. Alternatively, you could shoot against the light so that less light falls on the person's face. This makes it easier to separate flash and constant ambient light. As a result, working with the flash becomes more convenient. Let's consider an example of such a situation and start by taking a portrait without a flash. We set the camera settings to ISO 100, aperture 1.4 and a shutter speed of 1/1600th of a second, orienting towards the brightness of the background. The face in this case appears dark. If we want to make the face brighter by changing the exposure, the background will start to be overexposed. And at this point, we either have to accept that the background is overexposed or choose a location with a darker background, which we don't want to do, or go back to the previous settings and illuminate the dark face with a flash. That's what we'll try to do. So let's begin. The shutter speed 1/1600th of a second, chosen due to the overly bright light outside, is clearly shorter than the sync speed 1/200th of a second. For this example, we've also reduced the aperture to 4.0 so that the curtain shadow is more visible. In our camera, the shortest shutter speed at which the shutter curtains will be fully open, allowing the flash to illuminate the entire frame, is 1/200th of a second. However, a shot taken at this speed would be overexposed. So we need to somehow deal with the overly bright light. To solve this problem, we'll use a flash with a high-speed sync mode again. This will allow us to fully illuminate the person even at shutter speeds shorter than 1/200th of a second. Remember that when you enable this mode, the flash immediately becomes about 2 stops less powerful in exposure and starts functioning as continuous light. Therefore, changing the shutter speed will simultaneously reduce both the brightness of the background and the brightness of the face. Do you remember how convenient it was for us to work in the example with the evening sky when we could use the shutter speed to separately adjust the brightness of the background and the face? We can't do that now. What has changed? It became too bright, which forced us to use shorter shutter speeds and high-speed sync mode. But what if our flash doesn't have such a mode? Can we somehow simulate the darker conditions we find convenient and reduce the amount of light reaching the lens? Certainly. Enter the neutral density filter, also known as a neutral or neutral gray filter or ND filter. The ND filter reduces the amount of light and allows us to set longer shutter speeds. In our case, by putting an ND8 filter on the lens, we were able to photograph with a flash at a shutter speed of 1/200th of a second, and the background still looks dark enough. Compare the two methods and notice that high-speed sync forces us to increase the flash power. Of course, if we weren't interested in a shallow depth of field, such a reduction in the overall light flow could be provided in another way, by closing the aperture, but we wanted to shoot specifically with an open aperture to achieve a more blurred background. Let's summarize. If our camera has a focal plane shutter and we want to shoot with a shallow depth of field with a flash in bright ambient light, we have two main options to achieve a sufficiently dark background: using high-speed sync mode, available only in relatively expensive on-camera flashes, or using an ND filter, a method suitable for any flash. Therefore, using an ND filter is generally a much cheaper and more effective method. This is because the flash power in high-speed sync mode is reduced, meaning that when shooting with an ND filter, the flash has more opportunities to compete with bright sunlight. However, neutral density filter darken the image in the viewfinder of a DSLR camera, so framing and focusing can be challenging. And if you need to photograph dynamic scenes, the inability to set short exposure times may limit you. Moreover, different lenses may require filters of different diameters or special universal filter mounting systems, which increases the cost of the method. Lastly, with a filter, there's a higher likelihood of catching lens flares, especially in backlit conditions, even if you're using a very good filter. Therefore, some photographers who are very concerned about quality consider the use of any filters to be wrong. So there is no straightforward answer to the question of which of these two methods is better and more convenient. Whichever method we choose, we may encounter another problem. Both described methods reduce the brightness of the face, and often the power of an external flash is simply not enough to compensate for this darkening. In this case, some photographers resort to increasing the number of flashes. To increase the brightness of the light flow by 1 stop of exposure, you'll need 2 flashes. For 2 stops, you'll need 4 flashes. For 3 stops, you'll need 8 flashes, and so on. In conclusion, it's important to remember that we initially assumed that the duration of the flash pulse could be ignored. However, naturally, the flash pulse is not infinitely short in time. It has a specific duration, albeit a very small one, on the order of hundredths or thousandths of a second. Furthermore, the energy of the pulse is not uniformly distributed over this time period. There's a period of maximum spike, followed by a period of gradual decay. If the flash were triggered at the very moment when the shutter begins to move across the frame, one could obtain a reasonably good shot at a short exposure time even without using high-speed sync mode. However, camera manufacturers don't see the point in providing perfect synchronization of flash and shutter for such shots, as the energy of the pulse is distributed unevenly anyway, resulting in unevenly lit frames. That said, there are enthusiasts who use special synchronizers where the flash trigger time can be adjusted, or they use more intricate but very interesting methods. They then correct the uneven illumination of the frame in post-processing. Incidentally, these methods are useful for triggering studio flashes that lack a high-speed sync mode, especially if you want to shoot at short exposure times, such as capturing water splashes. If you're interested in such experiments, you can search for them online using the query high-speed synchronization hacking. Lastly, we'd like to inform you that for your convenience, we have compiled a practical guide to flash photography in book format. All links will be in the description of this video. If you'd like to thank us for the lessons we provide on this channel, you can use the Super Thanks button or check out other ways to support us in the description.